Hey guys, welcome back to the QST YouTube channel. Today we will be solving the Term 2 Week 2 Chemistry quiz. Let's get straight to it. For the first question, as we can see, the volume of the cylinder is 50 liters, and 1 mole of a gas is filled in that cylinder. At 0 degrees Celsius, what is the volume? Look, for every single gas, the volume of the gas is always going to be the volume of the container. So here it's going to be 50 liters. Number 2. First of all, for this question, we need to find the moles. So we do mass over molar mass. As we can see, the mass is 0.109 divided by 65.4, so we do 0.109 divided by 65.4, and we get 0.00166666. But we need to put it in scientific notation, so we make it 1.67 times 10 power negative 3 times 10 to the power of negative 3. For the second part, we do the exact same thing, but wait, we do not have the molar mass of hydrogen, or the mass. So we go to the balanced equation, and we find out that the coefficient of hydrogen gas is the same as the coefficient of zinc, which is 1. So that means they have the same amount of moles, which is 1.67 times 10 to the power of negative 3, as we found in part A. Now, to find the volume in RTP, we need to multiply the moles by 24 because it's in RTP. So then we get 1 we get around 0.04, but that's in decimeter cube. So from decimeter cube to centimeter cube, we multiply by 1000, which is 40. Number 3. For this one, we need to find out the moles of chlorine. We have the mass of chlorine, which is 14.2, and we divide that by 71, which is the molar mass of Cl2. We get 71 by multiplying 35.5 by 2. The moles is 0.2, but we needed to 3 significant figures, so it's 0.200. Part B. As we can see, the coefficient of NaCl is double Cl, is double chlorine. So we multiply the moles by 2 as well. So we get 0.4. Now to find the mass, we do the moles times the molar mass. We have the moles, which is 0.4, times the molar mass, which is 58.5. 0.4 times 58.5 will give us 23.4. Number 4. For this one, we need to balance the equation. So we have Na plus K plus H2O to give you an AOH H plus H2. Now to get the same amount of, now we need to balance the equation. Sodium is balanced, oxygen is balanced, but hydrogen is not balanced. So we need to multiply, wait a second. After some calculations you find out that the equation is 2Na, and don't forget to include the state symbols, because if you don't add the state symbols you lose marks. Solid because they said it's a metal dipped into excess water, which is H2O, 2H2O after you balance it. And H2O in this case is a liquid because they said water. To give you 2NaOH, 2NaOH, which is an aqueous solution, which is AQ, and hydrogen gas, which is H2, and then we add G right next to it because they said it's a gas. Now for part B, they gave us the moles. They're asking for the moles. We have the mass and the molar mass. So we do 4.6 divided by 23, which gives us 0.2. Yeah, it gives us 0.2. 0.20 because that's two significant figures. Now the moles of hydrogen gas is half of, it's gonna be half of the moles of Na, because as we can see from the balanced equation, the coefficient of hydrogen is half of the coefficient of sodium, so it's 0.1. Number 5. Okay. A rigid sealed vessel contains a mixture of 3 different gases kept under the same conditions of temperature and pressure. The volume occupied by each gas is always going to be equal to the total volume of the vessel or the room or the glass or the container. For this question, we need to first of all convert 108 kilograms to grams, which is 108,000. And now, so we can find the moles. We do 108,000 divided by 27, which is 4,000. And don't forget to put a full stop because they're asking for 4 significant figures. And now, for the second part, we can find out that the ratio of the coefficient to the moles is 1 to 1,000. And if we cross multiply, we find out we cross multiply by the ratio of the moles of the coefficient of oxygen to the moles of oxygen, we get that the moles of oxygen is 3,000. Now for part C, we have the moles and the molar mass, so we find the mass. So we do 3,000 times 32, which is 96,000. But that will be in grams. So from grams to kilograms we divide by 1,000, so it's 96.00. We put 0.00 because they're asking it to be in 4 significant figures. Now for this one, we have the balance equations and we have the moles. The moles for nitrogen is 1 in this case. And the molar mass for N2 is 28. So we do 1 times 28, which is 28 mole, 28 grams of nitrogen gas reacts with. So we do 3 times 2 because H2, and for each hydrogen it's 1, so it's 6 grams to give 20 grams. Because, no, not 20 grams. To give us 34 grams. Because we do the exact same thing. We do 2 equals 14 plus 3. 2 equals x over 17. And then we cross multiply, we get that x, which is the mass, is 34. For this one, we have to memorize that the condition when the temperature is 0 degrees Celsius and the pressure is 1 atmosphere is STP. Number 9. The volume of 1 mole of gas at STP is 22.4 decimeter cube. Number 10. The volume of oxygen in the gaseous state at STP is larger than. For every single gas, the volume of the liquid will be way smaller, which means that the volume of the gas will be larger than the volume of the gas if it was in the liquid state. For this question, we first of all we do 17.6 divided by 44 because they're asking for the moles, and then the mass is 17.6 divided by 44, which is the molar mass of propane. It's 0.4. Now, to find the atoms, we need to find the molecules first. To go from moles to molecules, we multiply the moles by Avogadro's number, which is 6.02 times 10 power 23, which we get 2.408 times 10 power 23. But they're asking for but we're not done. We need to multiply the molecules by the atomicity, so we multiply 2.408 times 10 power 23 by 11, which is the atomicity, to get 26.5 times 10 power 24, I think. Will give us around 2.65 times 10 power 24. So we go here, 2.65 times 10 to the power of 24. Number 12, which is the final question for this video. First of all, to find the moles, we do the amount of molecules divided by Avogadro's number, which is, wait a second guys, so divided 9 times 10 power 21 divided by 6 times 10 power 23, which will give us around 0.015. Wait a second. Which will give us around 0.015, which is 1.5 times 10 power negative 2. We have to make it in scientific notation, which is why I put it times 10 power negative 2. Letter B. Now to find the grams of oxygen, we have the moles, so we do the moles times the molar mass. So we do 0.015 times 32, which will give us 0.48 or 4.8 times 10 power negative 1 times 10 to the power of negative 1. Thank you guys so much for watching the QSC video. Good luck in your exam and see you next time. Goodbye.